Let's talk about naming polyatomic ions. And polyatomic ions are a group of nonmetal atoms that are covalently bonded as a chemical entity and have become an ion by either having added some electrons to become an anion, or having lost an electron to become a cation. This is just a small subset of the polyatomic ions that have been listed here. And there's a table in your book, table 5.10. If you're looking at the third edition of Atoms First, that you need to memorize that table. And you need to know that OH minus is hydroxide, and you can recognize that in a formula. And so let's write the correct names for the following compounds. Li is lithium, and sulfate is what SO4 2 minus is. So this came from lithium with a plus charge, sulfate with a minus 2 charge. And just so that you understand the formula, we needed 2 lithiums to balance out the charges so that the sum of the positives equals the sum of the negatives. Next one is sodium carbonate, where sodium had a plus 1 charge and carbonate has a minus 2 charge. We know that sodium has a plus 1 charge because it's in group 1A, just like lithium in the previous problem is in group 1A. They're both alkali metals. And the way you know that sulfate has a minus 2 charge and carbonate has a minus 2 charge, you simply have to memorize it. Next two compounds are both Fe iron and they've got NO3 in them, which is nitrate. So they're both some form of iron nitrate. They have slightly different chemical properties and physical properties, so they have to have distinct individual names. And the way we do that is by telling the charge on the iron in both instances and writing that number as a Roman numeral. So if nitrate is minus 1, that means each iron, to make this electrically neutral, in the first example, has to be plus 3. And there's only one iron, so it's iron 3 nitrate. Whereas the second example, each nitrate is minus 1. 2 times minus 1 is minus 2. That means that iron has to have a plus 2 charge. And so this is going to be iron 2 nitrate. Now notice the difference between nitrate, NO3, and now nitrite, NO2 minus, in this next two examples. Once again, they're both iron, but now they're nitrite as opposed to nitrate that we saw in the previous one. So we need to determine the charge on iron in both of these. Nitrite has a minus 1 charge. 2 times minus 1 is minus 2. This one is iron 2 nitrite, whereas the next one, each nitrite is minus 1. We've got 3 of them. In order to make this electrically neutral, that has to be iron 3 nitrite. So nitrate is NO3 minus. Nitrite is NO2 minus. And then, so that's nitrate, nitrite, and not to confuse the issue, but there's also nitride, which is just nitrogen, but it has a minus 3 charge. So you need to know the differences between your 8s and your ites and your ides. If you want to look at this column over here with chloroxo polyatomic ions, there are actually 4 versions of this, if you will. Perchlorate is ClO4 minus, chlorite is ClO3 minus, chlorite is ClO2 minus, and hypochlorite is ClO minus. So 8 and ite doesn't refer to the number of oxygens that are in a compound, or doesn't refer to the charge in a particular compound, or for that matter, the number of oxygens, they're all relative to one another. And that in terms of, we've been looking at 8s and ites in terms of nitrate and nitrite. The 8 has one more oxygen than does the ite, and some compounds have even more oxygens or fewer oxygens. So if you got even more oxygens than the 8, you become a per-8. If you have fewer oxygens than the ite, you become a hypoite. I know this is confusing. It just takes practice and sitting down and thinking through these to really need to memorize this chart, because you'll be having to write chemical formulas and chemical names and recognize them, not just in this course, but in every subsequent chemistry course that you take. So silver 1 sulfite. Silver is Ag. Sulfite, if you look above, it's SO3. That sulfite has a -2 charge. We're told here that silver has a +1 charge. To make these balance, it's going to be Ag2SO3, silver sulfite. Whereas silver sulfate would be SO4. It's got a -2 charge. Silver is still +1, so that would be Ag2SO4. And silver sulfide, that's where we got simply sulfur as an anion. It's in group 6. Once you get a noble gas configuration, that means that 2 has a -2 charge. So this will be Ag2S. When we write the formula, we don't include the charges, and so that's why I scratched that out. So Ag2S will be silver sulfide. Barium acetate. Barium is in group 2A. It has a +2 charge. Acetate is C2H3O2-. C2H3O2. It's got a -1 charge. So to make this balance, we've got to put parenthesis around the acetate and use a subscript 2. Ammonium nitrate. Ammonium is NH4+. Nitrate is NO3-. So having one of each of these polyatomic ions yields the correct formula, NH4NO3. Ammonium nitrate is used in fertilizers and also explosives. Potassium cyanide, bad stuff, you want to stay away from it. Potassium, group 1, is K+. Cyanide, from the table up above, is Cn-. So its formula is just simply KCN, potassium cyanide. Sodium bicarbonate, baking soda. Sodium's group 1, +1. Bicarbonate, from up above, is a -1 charge. So sodium bicarbonate, NaHCO3. We haven't talked about how things dissolve in water in terms of ionic compounds, but let's just stop for a moment. So if we put some sodium bicarbonate into water, we would have sodium ions, and we would have bicarbonate ions floating around in that water. And lastly, magnesium hypochlorite. Magnesium is in group 2A, a +2 charge. Hypochlorite, from up above, is ClO-. So to make this guy balance out, we're going to need 2 times those hypochlorites. 2 times the -1 to balance out the +2 magnesium. So MgClO, the ClO is in parentheses, and a subscript 2. So those are some examples of some polyatomic ions.